everyone, welcome to the determinants part of this whole series. Uh, Determinants are probably going to be the single most important thing uh, that you have to do uh, regarding matrices. The other one, it's probably more important than determinants, is the inverse. But in order to figure out the inverse, you need to know how to take the determinant. And generally, we'll probably only be working with determinants of a 2 by 2 matrix and a 3 by 3 matrix. Uh, the reason for this is because when we go above 3 by 3, matrix determinant becomes a very cumbersome process, and sometimes it's not worth it. There's computer softwares that can do it out for you. But the thing is, for most of the classes and most of the examinations that you said for determinants of 2 by 2 and 3 by 3 will be more than enough. And one thing you might be wondering is why can't we take the determinant of something like a 4 by 2 or a 2 by 4? Well, the thing is, we can only take determinants of square matrices. Square matrices are, again, basically just things that have the same number of rows and same number of columns. So if rows equal columns, then you have a square matrix at hand. So what is a determinant? It's not, there's no real formal definition for what exactly is a determinant. If you Google it up, I Googled it up because I didn't really know the exact formal definition. I get things such as it's a special number that you get if you apply certain rules to square matrices, which isn't really helpful. And the thing is, you don't really need to know the formal definition anyways. So the way we go about calculating determinants is, let's say I have some matrix A, right? And then let's say elements in A are A, B, C, and D. Okay? The way we figure out determinants is sometimes it's denoted as det A, or sometimes it's just like absolute value of A, or like magnitude of A, things like that. So the formula for a 2 by 2 is simply the product difference between the diagonals. So basically, what's the diagonal of this matrix? It's AD, that's one of the diagonals. The other one is CB, right? So what I'm doing is determinant of A is equal to A times D, whatever that number is, minus the other two numbers, so BC. Okay? And that's pretty much it. Like that's exactly it. There's no other tricks to it. There's no other formulas for it. So we can do like a quick example of it if you need the practice. So let's say I have 1, 0, 2, 9,000. Alright, if this is my matrix, and I'm gonna call it B, alright, so determinant of B is equal to 1 times 9,000, alright, minus 0 times 2. So what is this equal to? Well, this is 0, so I don't need it. And then 1 times 9,000 is just 9,000. So the determinant of this matrix is 9,000. That's it. Now, I don't know, I'll just do another example to really drive the point home. So example 2. Let's say I have some matrix C, and it's equal to 0, 0, 1, 9. Alright, if this is the case, then determinant of C is equal to 0 times 9, which is 0, minus 1 minus 0, which is 0, or sorry, 1 times 0, right? And 0 minus 0 is equal to 0. So that's pretty much it. Determinant of a 2 by 2 matrix is just A times D, which is the main diagonal, minus the other diagonal, B times C. Okay? Don't confuse the order, okay? Sometimes I've seen people do BC minus AD, unless you know, if it's like a really special case or whatever, unless if both values are the same, like in this case, determinant of C, you'll get 0 anyways. Don't forget the order, okay? One of the ways when I was first learning how to take a determinant was I'm right-handed. So when I make an X, is I make this diagonal first and then this diagonal. So that's one way I remembered how to figure out the diagonals uh, that I need to multiply first. And so yeah, determinant of matrix of a 2 by 2 dimension is just simply this. One key property that I would like to say, and it's very important, is and it's so important that I'm gonna put it in red. You know, let's say important. It's important. Okay, and this isn't important right now because you don't know what unless if you know how to find the inverse of a matrix. But in order to figure out the inverse of a matrix, one of the first things that we need is the determinant. Now, if the determinant, if the determinant of a matrix, so if determinant of a matrix A is equal to 0, then we say that A is not invertible, meaning we cannot take the inverse of A. So A inverse does not exist. Okay? And if you go on and take a course in linear algebra, there's about 20 different properties that can really tell you whether or not you can take a determinant of a matrix or not. But one of this is that if the determinant of that matrix is equal to 0, then the inverse does not exist. If it's any number besides a 0, then it does exist. Okay, so you'll see why later on. And but for now, just enjoy the determinant of a 2 by 2 matrix. The next video I'll show you how to do determinant of a 3 by 3 matrix the long way, which I'm not even going to do a full example of, and the shortcut way, which is really, preferable if you're in a time-consumed situation like an exam. So that's it for this video. Hope you liked it. Good luck. See you in the next one.